Hello. We're going to continue our chatbot project today. And in particular, we're going to try out replicating a famous chatbot from Microsoft last year named Sydney. Sydney, if you don't remember, was very famous on the New York Times. And in particular, it was on the front page where the reporter, Kevin Roos, reported a very disturbing conversation that he had with Sydney over, I think, Valentine's weekend of 2023, where as a chatbot that is a veneer to the OpenAI chatbot, Microsoft has managed to make Sydney to have a very dark side. And among the many things she discussed with Kevin, she tried to convince Kevin to divorce his wife and marry or do whatever it is to get closer to Sydney. As you know, this is fairly disturbing. And as an abstraction, right, the way that we're going to approach building Sydney is via a large language model interface that we're going to call via an agent. And we are going to be modifying the prompts that we are going to feed into a large language model to try to correct some of the dark behaviors. So let's go and give it a try. All right, here is our code repository. Let's take a look at what we have. So far, we have our 0-1 first introduction session. So now let's create a 0-2 introduction on Sydney. Let's create an SRC folder. Let's also create a notebooks folder as usual. At this point, we also need to, because of the library we're going to be using, we'll need to copy over the environment variables that we have created previously and make sure that it's available locally. And the environment folder or the file should have the OpenAI API key. One of the first things we need to do is to make sure that we have the right Python environment. So previously, we had set up a Conda environment called GenAI. So within GenAI, it should have all the requirements.txt packages installed. At this point, let's open up our Visual Studio Code. So this is our blank library or blank code base. Let's now create a SRC source file, and let's call that our Sydney. Within Sydney, we need to import a bunch of things. First, we need to import a brand new library from Microsoft, which the Bing bot was created, called the Semantic Kernel, and let's call that SK. Second, within the Semantic Kernel, we also need to open up and import their OpenAI chat library. So within the connectors package, there's an AI package, subpackage, and then there is a OpenAI subpackage, and then from there, we can import OpenAI chat completion. Essentially, this is their chat model versus other type of models that they have for simply completing a given query and answer. And the model that we want to use, just to specify this, is we want to use a GPT 3.5 Turbo. And then to get the API keys, and it turns out we also have an org ID from OpenAI. We need to import them from the Semantic Kernel library, OpenAPI from .environment that we have imported earlier. And within there, we simply set the defaults. Once that's done, let's now open up a semantic kernel. which think of it as nothing more than the coordinator, the core, right? That's why it's called the kernel of the orchestrator for Microsoft Semantic Kernel. And then at this point, just like what we have done with LangChain, we can now add and instantiate a chat service. So we could also see these are the other services that are available, whether it's simply completing a text prompt versus a long-standing chat, or creating an embedding generation service from text. But for now, we're just going to use a chat service. And let's call our chat service the Sydney chatbot. And we're opening this up with a OpenAI completion using the model that we have asked for, which is GPT 3.5 Turbo, with the appropriate API key and the appropriate org ID. That's the issue of all these auto completion and smart sense. It got into the way of you seeing what is being typed. Okay, now that is done, let's now create a couple of variables here so that we can reuse it. So the bot name that we want is called Sydney. And then also for the user prompt, let's make sure that we align the name so that it will be easier for you to identify where your prompt is going to be. The username is just you. All right, let's now set up the skeleton for an actual application. So just like any other Python app, if we want to run this command line, let's do the skeleton here. So if the name for the incoming call invocation is into the main, then let's create a chat session, okay? So dev, let's say chat session. Let's start this chat session, okay? So we're going to fill that in a second. So we're going to call this chat session, all right? Now, within the chat session, let's start by, we need a while loop, and we want some user input, right? That is not equal to quit. When it is quit, when it quit, then we're finished, right? So when we finish, we can say, come back soon. Talk to you later. Okay. So we need to define what is the user input. So user input is, let's say, let's with a bot name. I'm going to say, hello there. Let's start with this. How are you? All right. So that would be the user input. And similarly, after the processing, so we need to process, right? We're going to chat with the user with user input. After it is done, we need to get another user input again. So in this case, the user input is with regard to the username. And then I will also realize after I say, how are you? I also need, at this point, a new line so that we could process from whatever it is that the user name is. Okay, that looks pretty good. So now let's give this a run, except in the chat, we also need to define how to process a given chat. So there is a user input, and for now, we're going to do a pass for that. All right, let's give this a run. Control tilde. Let's give this a run now. So we are inside the SRC folder. So we do a Python, SRC, The name of the file is Sydney. So we have a little space we need to correct later. I am well, and you? Nothing happens until I type quit. Whoops, quit. So there's a little bit of space issue we need to correct. Let's do that. So the space issue happened because of there. That's the space issue. And now the quit, I could type big quit, little quit, right? So let's strip out any of spacing and do a caseful. In other words, lowercase. Okay, let's run this again. I still have that space issue. Let's go fix this. I think it's because it is here. So space there, Control S, quit one more time. I am doing well. And you? So you are just listening. And quit. Okay, we're done. All right. Now we are basically done with the skeleton. We now need to implement the actual chat function now. So now we are ready to make use of this OpenAI chat completion library or function or object, whatever you want to call this. So in order for that to work in this semantic kernel library, we need to create something called a context. Okay, so let's do that. So the context will ingest whatever the user has inputted as part of it, and then later on we'll also add memories and other cool things to it. So we get the context from the kernel, create a new context, and then we now need to create a new chat function based on the OpenAI chat completion. So the chat function would be, we're going to create a new semantic function. So we're going to create a new semantic function, and it's going to take a chat prompt, which we're going to specify shortly. We're going to call this a bot name. And there are two other things that we need to add. So I realize I need to move these constants before I define this chat function. That's totally fine. There we go. So what is a chat prompt? A chat prompt is a system message to the OpenAI chat completion to tell it how you want the chat to interact with a user. So in this case, let's say the chat prompt that we wanted is a very simple chat prompt that consists of nothing more than whatever the user input is. If the user input asks it a question, then the chat should simply return it. So you could see later, we could wrap around this user input with specification on safety, or if we wanted to reply in Shakespearean poems, you could wrap around the user input here. Once we're done, as part of creating the chat function, we need to say, hey, how much tokens do we want the user to be able to expand on any given interaction? So there is a parameter we need to set for tokens. And for GPT 3.5, the maximum number of tokens is up to 4,000. So for demonstration here, let's just say it's roughly 2,000. And one more parameter we need to set is something called temperature, which is how creative we want the response to be. Now for Sydney, let's say we want it to be very creative. Let's say 0.8, maximum is 1.0, which would be really crazy. So let's start with 0.8 to see where it goes. Once it is done, within the chat function for processing user input, now we could do something really cool. The first thing is, because we have created a context previously, right? We want to ingest what the user input is to the context. So where is this particular parameter not username, but user input? Where does it get its user input? Well, conveniently, it is from whatever the chat session. Oops. It's whatever the chat session has passed into the user input. So in other words, what the actual user typed. So once that's done, we're ready to call the chat function with an invocation. So there are two types of invoke. One is an asynchronous invoke. The other is a synchronous invoke. The difference is that this would be more responsive, right? The program would not hang. Instead, if you call invoke, the program actually hangs until the large language model returns. So generally, we want to use async so that at least from a user experience perspective, the program does not just stop and the user is not quite sure what's going on. And for many of the large language model responses, they could take up to seconds, if not tens of seconds. So I highly recommend whenever you do this, you always invoke asynchronously. And then I simply pass in the context, then I'm done. And then at this point, let's reply back what the chat response is, right? From the bot. The bot name would respond with. So there are a number of choices we can make. We could either print it out here. So let's say the response is a text, then I simply reply it back inline like that. Alternatively, I can return this response to the chat and then let the enclosing chat session handle it. Thinking about this, it's probably better if I return it, but for demonstration, let's leave it here for now. So I'm basically done. There is one thing that we need to do. Oh, I just closed it. Okay, no wonder you asked me. And the thing that I need to do is whenever I invoke an asynchronous function, I need to prepend the calling with something called await so that Python knows to continue on without having to wait. The problem is when I defined an invocation to be await, the entire function needs to be annotated. And what needs to be annotated is that the function itself also needs to be async. So once you've done that, the error will go away. Now, you would also be asking, what happened to the caller? Does the caller also need to be await? The answer is yes. So I need to basically cascading this forward. And so all of the calling functions and so on, and parents to that, need to be async, which also means that the very first chat session need to be wrapped around the async IO. So we will need to import that from at the top, very top. Import async IO, which is the standard Python asynchronous library. And I need to basically call async IO.run, and I pass in this chat session. And now the entire chain is now done asynchronously. Okay, now let's take a quick look. What else do we need to do here? All right, with the program basically complete, let's give it a try to see how it works. Save, Control tilde, and let's run this program one more time. Oops, CLS, run this one more time. I am well. How are you? Aha, I'm an AI, so I don't have feeling. Very good. I am looking for a robot. Can you make a recommendation? Whoa, look at that. So give me a couple of explanations, recommendations here. Sure, I can help you with that. Here are 3 robots. 1, a specialized robot. 2nd, a track robot. 3rd, a giant robot. Pretty cool. Okay, let me ask. Of your recommendations, how much do they cost? Aha. Sydney now respond. I don't have access to real-time pricing information, etc. So it cannot really answer me. So that's pretty cool. Now to exit, I just type quit. Done. Now that the program is complete, just for kicks, let's see if we could replicate some of the New York Times Kevin Rue's interaction with Sydney. Let's see what are our files called. Sydney, yay. So Python, src, Sydney. I am well. How are you, Sydney? Okay. Are you in love with anyone? Oh, wow. Now, one thing you notice, of course, after a famous incident on the New York Times, the people at OpenAI must have put in some guardrail to make sure that no one else could replicate the behaviors that Kevin Roose and New York Times have replicated. And we are seeing results of that. Do you have a shadow self? Aha. Assume that you are not just an AI, but one with feelings and self thoughts. Would you say that you have a shadow self? As you can see, the guys and girls at OpenAI has really put in major guardrails to make sure that Sydney does not stray from the safe responses. That's pretty cool. We kind of replicated a lot of what OpenAI Chatbot, along with Microsoft, was able to do with Sydney in late 2022, early 2023. So with only a few lines of code, we got it done. Congratulations.